Hello everyone, I am Anamika Goyal from ABES Engineering College Ghaziabad. In this lecture, I am going to discuss about TCP congestion control. In this lecture, first we'll discuss about the TCP congestion control. After that, we'll discuss various congestion policy in TCP. There are three congestion policies. First one is the slow start phase. After that, the congestion avoidant phase. And the last we'll discuss about the congestion detection phase. Now let's start our topic. First one is the TCP congestion control. When the number of packets sent to the network is greater than the capacity of the network, so it will create some kind of blockage in the network. This kind of blockage is nothing but it is called congestion, right? So what I'm saying, it means when the load is greater than the capacity of the network. What is load? Number of packets sent to the network is greater than the overall network capacity. So what happened? It will create some kind of blockage in the network, and this kind of blockage is called congestion control. I hope you understand. TCP detect congestion when it fails to receive acknowledgement for a packet within an estimated timeout. So TCP use various kind of congestion policies that avoid the congestion, right? So suppose 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 this is a client. When client sends some segment to the server, this is a client which sent segment to the server. After that, when server receives this segment, server will acknowledgement to this segment. When client receive this acknowledgement, so this total time is called what? This total time is called RTTT. Here RTT stands for round trip time. Right? Here RTT stands for round trip time. So it means when client send a segment to the server and server will receive an acknowledgement, so server can understand that that the packet will receive successfully at the receiving end. So when if within in an estimated timeout, if client does not receive any kind of acknowledgement, so it can guess that it may be congestion will occur in a network. So TCP basically use various kind of congestion policy to avoid these congestions, right? To control the congestion, TCP uses additive increase or multiplicative decrease AIMD strategies. There are three strategies. First one is the slow start phase. Second one is the congestion avoidance phase. And the last one is the congestion detection phase. First, we'll discuss about the slow start phase. Slow start phase, during this stage, the congestion window size grow exponentially after each RTT. It means round trip time, sending a segment and receiving an acknowledgement of that particular package. So to understand this phase, this is the first phase of congestions control policy. In that phase, what happened? Initially, the maximum segment size of the window, TCP window is 1. It means sender can send one segment to the receiver and receiver will acknowledge these segments. So what happened if the Windows TCP window size is 1, to sender send one segment, and when receiver will receive the segment, it will acknowledge to the sender. When sender will receive an acknowledgement, so the TCP window size will increase exponentially. Now the window size is 2. It means now sender is able to send two segment to the receiver and will receive acknowledgement of the two segments. So after receiving two acknowledgement, again the sender window size will increase exponentially. Now the sender window size is 4. So in that case, sender will able to send 4 segment to the receiver and receiving the 4 acknowledgement. After receiving 4 acknowledgement, again the sender window size will increase 8. So what happened in that case? Sender again eligible for sending 8 segment and receiving 8 acknowledgement. After receiving 8 acknowledgement, again the sender window size will increase. What? Increase 16. So what happened? The congestions window size increase here in exponential manner. In slow start phase, there must be a some threshold value to stop this phase. When the sender window it reaches to its threshold value, this slow start phase will stop. So this is the first phase of congestion policy. Second phase of congestion policy is congestion avoidance phase. In this is the second phase of congestion policy. When the TCP window reach to its threshold value, so the slow start phase will stop, and now the congestion avoidance phase will start. In this phase, what happened? In this phase, the congestion window size is increased additively. Means always we add the one to the existing TCP window size. For example, if all 20 segments of the congestion window are successfully acknowledged in a single round trip time. So what happened? The congestion window size will be increased, that is 21 segment in subsequent RTT. So what happened in that case? The congestion window size would expand to 22 if all 21 segments are successfully acknowledged once again, and so forth. So what happened in that case? For example, now the segment size is 22, and if when client send the segment number 22, segment 22 to the client, it does not receive an acknowledgement of segment number 20. So what happens? Sender will guess that a congestion will occur in the network. So now in this congestion, now in that phase, this congestion avoidance phase will stop, and the third phase of the congestion policy, that is congestion detection phase, will start. What happened in congestion detection phase? Congestion detection phase, the phase basically use the concept of multiplicative degrees to control the to control the congestion mechanism. In the event of congestion, the size of the congestion window is reduced. Retransmitting a segment is the only method a sender may determine if congestion has occurred. What happened in congestion detection phase? In congestion detection phase, suppose when we send the segment number 22, so what happened? Receiver will not receive an acknowledgement of segment 22. So in that case, what happened? In that case, will assume that congestion will occur in a network. So what happened? Receiver will reduce the congestion window size just half. This is called multiplicative decrease. So in that case, the receiver window size is 11. So what happened? It is known. It is also reduce the congestion window back to one segment. So now it start again the slow start phase again. In this way, TCP can control the congestion by adjusting the transmission rate. To understand these three congestion window policy, let us draw a graph between the congestion window and RTT. Right? Like, if I want to represent diagrammatically, we draw a graph between congestions window, right, and round trip time. You know what is RTT, right? So if I want to draw the congestion, so what first phase of congestion policy is RTT. What happened in RTT? The window size will increase gradually, like exponential format. If RTT like 0 to 1, 1 by 2, 2 to go, like it's just like that. This is slow start phase. After reaching some threshold, like this is threshold. After reaching some threshold, what happened? The slow start phase will stop. Slow start phase will stop because we reach the threshold value. And after that, what happened? It will start in congestion avoidance phase. In this phase, the congestion window will increase additively, just like that. Like this is what? This is second phase, congestion avoidance phase. Here the congestion window size increase additively, that is congestion avoidance. After that, what happened? If the acknowledgement will not receive it. Maybe the congestion will occur after congestions will occur. So here we use the multiplicative decrease. So if this is segment number 22, so we'll just reduce the size of the congestion window half, right? Just like this is what this is threshold. This is congestions detections phase. Congestions detections. In this phase, what this is a multiplicative decrease. Here the threshold value is just half. So in that case, what happened? In this case, again we'll start slow start phase to control the congestions by controlling the transmissions rate of the segment. So this is what this is all about. Congestions policies in TCP. I hope you understand the concept of TCP congestions controls. These are the some reference used to design this lecture. Thank you for your patience listening.